Hi students, welcome back to my channel. In this video, we are going to discuss about basic data types or fundamental data types in a C language. In C language, the basic data types are the fundamental data types that are directly supported by the C language. The fundamental data types are basic data types directly supported by the C language. These data types define the size and type of variable values that can be stored. What is a variable? Variable can store some values. For example, if you are declaring a variable as an integer, it stores 2 bytes of memory will be allocated. Uh, Float means 4 bytes. Character means 1 byte like that. Okay, na? So these data types define the size and type of a variable. Here, what is the type of variable? So if you are declaring a variable as integer, it's an integer data type. If you are declaring a variable as a float, it is a float data type. The basic data types in C include integer. So used to store integer values are whole numbers. So typically integer takes 2 bytes or 4 bytes depending on the system. So on 16-bit system, so the integer takes minus 32,768 to 32,767. So basically, because 2 bytes no, so 2 to the power of 16. Byte means group of 8 bits. So 2 bytes means group of 16 bits. So 2 to the power of 16 equal, because why 2 here? So 2 means a binary system. So because system understands only binary values. So 2 to the power of 16 equal to 65,536. So that include minus 32,768 to 32,767 on a 32-bit system. So this much of memory will be allocated for a integer. Next, float. So used float is used to store single precision floating point numbers. So number with decimal points. So float nothing but it stores numbers with decimal points. For example, 3.14. Okay, na 3 is a multisa, 14 is a decimal points for that. So generally it is a 4 bytes. So approximately, so single precision, there are two types of floats here. So float, double float. So single precision, double precision. Okay. So for single precision, it takes 4 bytes of memory will be allocated when we are declaring a variable with a float. So generally approximately 3.1, 3.4 e to the power of minus 38 to 3.4 e to the power of plus 38 with 6 decimal digits of precision. So I will explain what do you mean by this 6 decimal digits of prescription while I am executing the code. Generally 3.4 e to the power of minus 38 is equivalent to 3.4 into 10 to the power of minus 38. So 3.4 is the mantissa and 10 to the power of minus 38 is the exponential. Okay. Next, double. So used to store double precision floating point numbers. It has more precision up to 15 decimal digits of precision will be there in this. Okay, typically it stores 8 bytes. Okay, so range approximately 1.78 minus e to the power of minus 3082 to 1.7 e to the power of plus 308. 15 decimal digits of precision will be there here. Next, character data type. So used to store single character or small integer, typically 1 byte of memory allocated when you are declaring a variable with a character data type. The range is for signed character minus 128 to 127, for unsigned 0 to 255. Next, void. So you know already void. So void means so many programs we used to write void. So represents the absence of data type. So it is used in functions that do not return a value or to define generic pointers. So void does not store any data. Void does not store any data. Next data type is a Boolean data type. This Boolean data type introduced in 99 here used to store boolean values either true or false only one byte. 0 means false, 1 means true. So this I'll explain through a code. Right. So the various fundamental data types are going to explain with the help of a code. So already hash include stdio.h int so int a is a variable. So declare as an integer data type. So here it stores 2 bytes of memory will be allocated to this. Float 4 bytes of memory allocated to this. I told you already. Float means 6 decimal digits precision will be there. 6 decimal digits means suppose here. So decimal means so 1, 4, 4, 5, 5, 6, 5, 8. Total how many numbers are there here? 1, 2, 3, 4, 5, 6, 7, 8. Even you are writing 8 decimal digits here, but it can display up to 6 digits only. 1, 2, 3, 1, 2, 3, 4, 5, 6. Up to here it can display. So remaining it won't be display. Okay. So double means up to 15 decimal digits it can display. So here, for example, I wrote some numbers. So up to 15 digits, up to 15 decimal digits will be displayed. So next character 1 byte. So this is a character, single quote, nothing but a character. Boolean means one byte. So E is a variable, so which can store either 0 or 1. 0 means false, 1 means true. Okay, let me display this code on the screen. Printf integer. So integer means only 2 bytes, so no problem. But coming to here, very important this printf float. See here, 0.6 means so it is a float data type. So 4 bytes has been allocated for the float data type. Okay, now so up to 6 decimal digits will be displayed on the screen. Even you are writing more decimal digits in your code. We are assigning more than 6 digits, but it can display up to 6 only. Remaining will be ignored. So double, okay, now double 1.15. So it can display up to 15 decimal digits. So even you are writing more. For example, I'm writing here. I'm writing more. Here I'm writing more. It can display up to 15 decimal digits only. Okay, now for example, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. See, I assigned 21 decimal digits to the double float here. So let me let me check how many digits are going to this next character percentage t. So 1 byte and boolean data type 1. Okay, 1 byte only. Okay, already percentage d means it is used to display integer on the screen. So percentage f means display float values on the screen. Percentage c is used to display characters on the screen. And boolean data type means we are using 0 or 1 now. That's why we are using percentage d. Because boolean we are going to display in terms of zeros and ones. So zeros and ones are for integers now. That's why I should use here percentage d. Okay, let me execute this so that you'll understand very clearly. So next, compile and run. Look at here. So a equal to 10 displayed as it is. Float. See here. How many numbers are there here? 2, 4, 6. But how many are assigned here? 8. But it can display up to 6 decimal digits only. Double means I wrote 21 here, but it can display up to 15, 16 depending on the system. And character A and boolean 1. Thank you for watching this video.